Welcome back. Let's see if we can do something interesting here. I'm going to remove this line. Remember, we just have dragon and lizard. We're going to, once again, inherit or create a prototype chain up to dragon. And now here, let's check something. I'm going to do a for in loop. So I'm going to say let property in lizard, that is, loop through the properties in lizard. And let's just simply say console.log prop or property. If I run this, I see that the lizard has properties name, fight, fire, and sing because we've created a prototype chain. Now, the base object also gives us another interesting method that we can use called hasOwnProperty. If I do if lizard.hasOwnProperty and we give it a property name, so let's just give it prop, which we're going to loop over, and say if lizard has own property, then we're going to console log. What does that mean? Well, we're saying with this method, only log whatever lizard has as its own property. Let's see what happens when I run this. I only get name and fight because lizard only has name and fight. The other properties are inherited from up the prototype chain. How cool is that? So we're not actually copying these properties from the dragon. As I said before, if the JavaScript engine doesn't find the property on that object, it goes up the prototype chain. For example, the hasOwnProperty is not part of lizard. So it goes up the prototype chain to dragon and then up to the base object and finds hasOwnProperty, and we're able to use it. And the beauty is that JavaScript looks for you through the prototype chain automatically. We don't have to do any weird .__proto._proto to find hasOwnProperty. It does it automatically. And I want to remind you, this isn't the same thing as the scope chain that we talked about. Remember, these are the prototype chains, and these are the scope chains. Different color chains, right? So keep that in mind. They work in a similar fashion, but they're two different things. Now, before I tell you why this is so useful, if you haven't already figured it out, I do want to warn you. What I've just shown you, well, you shouldn't really attempt. You might be asking yourself, hey, how come I haven't really seen this __proto before? It seems pretty useful. Why don't we see it everywhere? Well, this __proto, although we can use it here, you shouldn't really use it. Actually, you should never use it. It's bad for performance, and there's different ways that we want to inherit when it comes to prototypal inheritance. Something that we're really going to dive deep into when we talk about object-oriented programming. So we never want to manually assign the prototype chain and create that chain ourselves. It's going to, well, mess up our JavaScript compiler pretty badly. But I wanted to show you just how it works. And when we start talking about object-oriented programming, we'll learn proper ways of doing this. Now, let's talk about why this prototypal inheritance is useful. Let's think about this. Maybe pause the video, think about it. Why is this useful? The fact that objects can share prototypes means that you can have objects with properties that are pointing to the same place in memory, thus being more efficient. Imagine if we had a ton of lizards, right? And we just copied all this functionality of the dragon onto the lizard into a different place in memory. That can get overwhelming fairly soon. Instead, with prototypal inheritance, instead of just copying all this functionality into different places in memory, we have it in just one place. anything that inherits from Dragon will just use this one instance of this method, because the JavaScript engine is just going to look up the prototype chain, which makes things really interesting, right? For example, this hasOwn property that lives on the base object only lives in memory in one location because, well, we'll just use the prototype chain to look for it. And everything that inherits from the base object will get access to this. How cool is that? We're being efficient with our code. We're not repeating ourselves, and we're saving ourselves memory. And by the way, whenever we get undefined on something, let's say in here, I go lizard.haha, and I run this. I get a type error. Or if I go as a property, I get undefined. Whenever the JavaScript engine doesn't find anything up the prototype chain, we get these errors or undefined because it goes all the way up to the base object. And then what happens after we get to the base object? Let's find out. If I clear this, let me refresh, and say I have an object that we'll create. It's going to be an empty object. And if we do object.proto, well, I get the base object, where all objects are created from. But let me ask you this. What if I do __proto again, even higher up than this base object? What do you think will happen? We get null. Does that surprise you? Null means there's nothing there. And when JavaScript was created as a language, undefined was used for, well, we don't have that variable. We don't have something defined. Null meant there's absolutely nothing there. Because of its prototypal inheritance nature, we needed some way to say, hey, past the base object, there's nothing there. There's null. Some would call this a null pointer, pointing to null. It's the end of the chain. Sorry, I got nothing for you there. Throw an error, throw undefined, say something's wrong. We don't have that. All right, let's take a break and get into more prototypal inheritance in the next video.